Hello, and welcome to Sustainable Outlook, a podcast from global law firm K&L Gates, where we discuss the transactions, technologies, and trends in the sustainable economy. We hope you enjoy this discussion. Please reach out with suggested topics or guests, or questions about how we can work together to create a sustainable economy.
Welcome to this episode of Sustainable Outlook. I'm Molly Barker, your host for today's episode and an attorney in the environmental and energy practice groups at K&L Gates. I'm very excited to be joined today by Aaron Rothman, founder and CEO of Storm Sensor, a climate technologies company based in Seattle, Washington, that works with cities to map how water moves through sewer, storm, and coastal systems. Aaron has over 15 years of stormwater and remediation consulting experience working with cities across the United States. Aaron has previously served as VP and principal scientist at a Seattle-based consulting company, managing principal at a large international consultancy, and founder and managing principal of her own environmental consulting company. She has since founded Storm Sensor with the objective of mitigating climate risk by creating intelligent wastewater infrastructure. Thanks so much for joining us, Aaron.
Thank you for having me. Thanks, Molly.
So to get us started, can you tell me first about Storm Sensor's birth story, if you will?
Sure. It started a ways back before IoT was a thing. So when I was a consultant and we brought in a stormwater group, we started losing money instead of making money, and we couldn't figure out what was going on. And it turns out that we had an incredible team of people who were very busy responding to storm events and collecting these samples, but every time it rained at the office, they had to go sample at the sites, but just because it was raining at the office, so here doesn't mean it was raining there. So they're going out like 4 times before they can collect a sample and we can bill their hours. And I said, that's the stupidest thing I've ever heard. Why don't we just have a rain gauge that texts us when it rains? And they laughed at me and said, why don't you go invent that? And I said, I will. I'm going to call it Storm Sensor. So that was that was maybe 2010 or 12-ish. It turns out that there are rain gauges that text you when it rains. Now, they're very easy to come by. Then they're like $10,000 a piece, which is ridiculous. I didn't think much of it because my background is science and business, not hardware and software engineering. Until a few years later in 2014, I was in San Francisco where everyone was in a startup. So I said I was in a startup too. It's called Storm Sensor. And I was also kind of exploring things that I could do outside of consulting. And I started looking at competitors. Like I said, there are rain gauges that text you when it rains. And then I talked to accelerators in the Bay Area. I talked to accelerators in Seattle. I moved back to Seattle. I took a product management class using Storm Sensor as my product and kind of took the leap when we had an opportunity with an accelerator locally in Seattle. And at the time, I was focused on my background, or what I knew from my background, which was industrial and construction stormwater compliance. It turns out that not every industrial or construction facility wants to be compliant or know when they're not. So looked at other market opportunities and started talking to cities and learned that we have almost completely unmetered utilities in stormwater and sewer, which blew my mind. And I realized if we took out all of the water quality parameters like pH and turbidity and conductivity, focused only on flow and temperature as one quality parameter, we could significantly reduce the cost. We could basically eliminate the maintenance required. We could increase the battery life, reduce power draw, all these things. And instead of installing a sensor that communicates with an app, we could install tens or hundreds or thousands of sensors across the community and really understand and map how that water is moving. And then with climate change being such a big issue, finally, or at least we're talking about it finally, understanding what's happening within our stormwater and wastewater and coastal systems and mapping that to both real-time weather conditions and also longer-term climate conditions so cities can see how all that interrelates. That's kind of how it started and how I got to here.
Yeah, wow, that's super interesting. So I'd love to hear then, you talked a little bit about your background with respect to working in remediation and due diligence. What made you move away so permanently from your past? Was it the intrigue of I want to invent this thing that I think is going to be pretty critical to what I think needs to happen to move us forward? Or was it, I need to change, I need to get out of this industry? What was it?
I was more the latter. So I'm sorry. Yeah, this is what you do. So I loved the science behind the consulting. I loved kind of like matching up the field work and the data with the regulations and making everything kind of match together. The issues that I had with consulting, or at least environmental consulting, was that I worked primarily with real estate developers. They didn't hire someone to clean up these sites because they wanted to. They hired someone to clean up these sites because they had to. And we needed to clean up sites so they could get their construction loans and they could close on the loans once the regulators approved the cleanup work. So they had to do it. They hated that they had to do it. They didn't understand it. So no matter how beautiful your work is or how much you've worked to reduce costs, it's too expensive, it's confusing, it's hard. And then you go to the regulators, and by virtue of probably humanity, they didn't trust the work that was done. So no matter how good of a job you did, no matter the samples you collected, no matter how well you met the regulations, they could still say, I don't care. I still want you to do more sampling after there's already building there. So it was a very frustrating job. And I wanted very badly to work with people who really wanted to work with me on projects that we could be proud of and excited about together. And I wanted to do something that was simple, that was clear, that was beautiful, that we could make, understandable to communities as a whole. And obviously, stormwater was the low hanging fruit on that. And I realized that storm sensor was something, because I needed something to do. I couldn't just leave consulting.
Well, and it seems like a much more collaborative environment.
It is, and it's so much fun, especially with the climate work and the risk and resilience mapping that we're doing. We're talking to sustainability managers and resiliency officers across the country, and they love their work so much, and it is so much fun to work with people who have as much joy as we do in
Totally.
The presentation.
I can appreciate that. Absolutely. So can you talk to me a little bit about what the nuts and bolts are of the products that Storm Sensor provides from a both software and hardware perspective?
Sure. So I can start with SURFR. It's our Stormwater Urban Flood Risk and Resilience Index. So what we do is on a parcel basis, we can map flood risk across the community with rating it from 0 to 100. And then every parcel within that is between 0 and 100. And we look at 9 different parameters that include everything from elevation to income to determine the risk factor for a given parcel. And then on top of that, we look at the resiliency aspects, so looking at appraised property values, ecosystem services. We put together kind of a decision matrix based on those numbers and then overlay that with the risk. So you can have, it's almost like an automated, well, from our end, slightly automated from your end, you can have a map of every property in your community and exactly what steps you can or should take to make it more resilient to climate risk, primarily urban flooding. But urban flooding often ties really closely to heat island impacts as well. So that's on one hand. And then a lot of times those risk factors or high risk opportunities that we identify in those maps will trigger efforts to understanding how water's moving through these systems. So we'll deploy our sensor networks. We monitor depth, velocity, and temperature. We typically do maybe 20 sensors per linear mile. So we have a pretty dense network. And we're collecting that data every 5 minutes, sending that data every 5 minutes. And cities are using it both for maintenance purposes, a lot more lately on traffic, managing traffic systems. Once we hit critical depth below
Makes
ground,
sense.
right before you hit flooding. Yes, so managing how people are moving through these cities. And then we do a lot of work looking at capacity of these systems. So we can differentiate different inputs into a storm system. For example, an easy example is on the coast. So we can see tidal impacts versus stormwater impacts versus baseline flow conditions. And we have systems that we've identified that would operate beautifully if they just had stormwater moving through them. But because they have tidal impacts, that tailwater fills up the system, and they're seeing flooding almost every storm event. So we can actually measure the difference and show this. I just think it's so cool to have the charts with different colors and all that mathematically separated. So then cities can take that and design capital improvements or implement relatively quick fixes like tide gates or pumps or valves or anything to move that water elsewhere.
Totally. Wow. That's fascinating. So are these technologies unique from other stormwater control measures in, the industry from a national perspective, or is storm sensor kind of trailblazing in this area?
I would say that the thing that we're doing differently, because there are companies that do sensors, there are companies that do software, there are companies that do risk analysis and modeling, but each of those companies tends to focus on that pipe or that system. What we're doing is tying the whole ecosystem together. So including the urban environment or the suburban environment, what's happening below ground with what's happening with weather conditions and surface water conditions, and kind of giving a community-wide approach and a community-wide, community-focused solution.
I mean, that's great. So I assume I know the answer to this, but I'm not sure based on what you've said so far. Has its data been used to help municipalities that are approximately situated with one another to collaborate together on a large climate strategy for how to proceed with what's becoming more frequent extreme weather events as they're kind of all patchwork together?
Right. Well, it's really interesting because there are some communities that we're working in that are very much appreciative of their own approach and less so of each other's approach. And then there are some communities that we're working in and starting to work in Florida, for example, where they're all recognize they're in the same sinking boat in that area in particular. So being able to show how the water moves through and between these systems and how they can implement different gray or green infrastructure improvements to cause an appreciable difference to all the communities instead of just one or two blocks within one. So we're starting, and it's a lot of fun to work with the cities that are excited about working together.
Yeah, I bet, especially because, that's part of the process is coming to the realization that climate change doesn't really recognize boundaries of any sort. So, yeah. So what would you say, as wetter weather becomes more frequent and more extreme weather, all of these types of more manic weather becomes more common in our day and age, what would you say of these obstacles is kind of storm sensors' biggest challenge right now?
I think part of the challenge is going up against, or not even against, facing known solutions that address a part, whereas we're trying to address the entire ecosystem as a whole or the entire community as a whole. We have our risk maps. We compare them to FEMA. People are used to FEMA. They have to follow FEMA. But we know, and I think FEMA also knows, that when you look at just historical flood conditions or just geographic or geologic parameters, that you're not getting the whole idea of what flood risk really is. So bringing in that social concept and that community concept into flood management, but then also the infrastructure monitoring and pulling that back into community equity and management as a whole. So telling that story, which hasn't really been told from a private company perspective before, it's been a really fun learning experience. And when people get it, it's very exciting. And when they don't, then we can absolutely sell stormwater monitoring sensors.
Mm-hmm. Yeah. So I guess on that relative topic, based on your experience, does failing stormwater management, disproportionately impact public health of EJ communities? And if so, what are ways to address that specifically, in certain areas that are disproportionately impacted by climate change?
Yeah, so it's really interesting to see how there is that impact. So a lot of times in areas that have very dense populations, that have low income populations, so on one hand, that density, regardless of income, is going to put a higher stress on the sewer and storm systems. So you're already going to have that stress factor. When you add income into it, either a neighborhood within a community or a community as a whole that doesn't have a lot of funding, they're not able to address the issues within these systems because the money's not available. And if there is money that comes available, the first thing that they're going to think of is not necessarily going to be making sure that they have playgrounds that have permeable surfaces so that they have stormwater moving into the ground. They're going to think about ways to protect their children from walking to school and not getting shot on the way. So it's a really interesting balance of understanding what those risk factors are and what positive impacts can be made, but then also balancing those needs with the expectations and requirements of those communities as well.
Well, hopefully, as they say, we can and we should do better. So hopefully we continue to move and provide, more funding, whether if it's in a place that doesn't have a strong tax base, ways to get more funding into those communities definitely seems to be the key.
Absolutely. I was talking to a water district that manages a county last week, and he was talking about how they have, there's so much funding available. So they're receiving grants from which they distribute the funding. The cities that can afford someone to write the grants are the wealthy white communities. The cities that need the funding, they don't have extra people that are focused on making sure that the kids have safe playgrounds that are, available for stormwater management. So they don't even have the people available. So they get in trouble because they're not issuing grants to the communities that need it the most, but the communities that need it the most don't have the resources to write the grant applications in order to get the funding.
Yeah, it's like we don't have somebody that, graduated with a degree in grant funding, which some people do, it's a circular issue,
Yes, absolutely.
How do you, anticipate stormwater management evolving over the next 10 years? How do you anticipate and how do you hope if those are different?
Well, I think we're acting on our anticipation, or I guess, as you said, our hope. So like I said, like tying it as a community issue or ecosystem issue as a whole, not managing that pipe over there, understanding how climate impacts our systems, whether it's from flooding or even drought, and how droughts can impact the performance of our infrastructure. And then how individual people and communities and neighborhoods within those communities are impacted by the functioning of our storm systems or our sewer systems or heat indexes or anything related to how climate's impacting our communities as a whole. So I guess we look at it as, I call it digitalization for climate resilience, so DSCR, and how we tie all of that together so we actually have the data so we can understand how these things are interacting and what we can do to tweak one and improve something else over there.
Do you think that there is a chance that in 10 years there could be potentially whole cities that are fully equipped to manage extreme weather that at that point might not feel so extreme because it's normalized? Do you think that's possible?
I think so, to a point. There are going to be times when you have a 14-foot storm surge. I just don't know what you're going to be able to do about that. And infrastructure and houses, I guess we have to withstand it, but people can't survive it. But as far as bigger storms and larger storms, a lot of what we see with our data is that with a lot of our cities recently, we've done these analyses where we look at significant storms like 5-year, 10-year, 20-year storm events and how those are affecting their systems because their systems are designed to handle 5 or 10 or 20-year storm events. We haven't seen any of those in the last year. They've all been small storms. In many cases, these cities are dealing with droughts and their systems are flooding almost every storm event. So we have to be able to manage the basic functioning of our infrastructure in addition to what's happening with the additional impacts from climate that we're seeing right now. So
totally.
We have a couple of big steps to take. And once we're there in 10 years, it will be beautiful, very Jetsons-like, I think.
Yes. So I'm curious to know if you have any, particular countries in mind that you think are managing, urban flooding, sewage overflows, and water pollution control measures particularly well that you feel the United States should be looking to?
I think it varies. So it's even interesting within the United States. So we have combined systems, which are outdated and not technically legal anymore, primarily in the Northeast and the Midwest. I think there are 887 combined systems. The rest of the country, for the most part, Seattle and I think San Diego accepted, is on a separate storm system. And then how they manage those separate storm systems, obviously that's the ideal. But then at the same time, I have a small soapbox related to this where Jersey City has a combined system. They have netting facilities. So when there is an overflow and the stormwater is moving through this and stormwater and sewage is discharging into the rivers, they have nets that capture all the garbage. There's a lot of garbage.
Wow.
Once you switch to a separate storm system and you're releasing the stormwater into the rivers or lakes or whatever, there's no netting facility. So all that garbage is just going out in addition to the contaminants associated with it. So I feel like I don't know of a single city that is actively addressing and treating all of the issues related to stormwater, let alone the combined sewage overflows. So I wish I could give you a shining example, but yeah.
All of them have work to do.
Yes, they really do. When you see it, it's pretty shocking.
Yeah. And I bet it's especially so, with each city having their own history, each of them started at different times. So they're kind of working with, the history they were given to, the infrastructure history, trying to work from that, I bet.
Very much so. And then people, they are able to do all of this work based on taxes or stormwater utilities. And if people don't see or feel a problem, they're not going to want to spend money to fix something that doesn't directly impact them.
Of course. Yeah. That's the reason why, a lot of money doesn't get spent on things, right?
Yes.
Yeah, unfortunately. So I am curious to know what is Storm Sensor's next big goal for you guys? What are you hoping to achieve looking forward?
So obviously we're focused primarily on coastal and inland communities in the United States. But our next steps are looking at, once we nail this country, moving into Canada and the EU. And we have partners in both locations that are helping set that up with us.
Awesome. That's really exciting. Well, good luck to you guys. That'll be a very, exciting opportunity and really fantastic once it kind of finally breaks ground in that regard. So thank you, Erin. And I want to thank all of you who are listening to this episode of Sustainable Outlook. We hope you will join us again soon as we continue to explore the intersection of environmental, social, and economic sustainability. Until next time.
Thank you for listening to this episode of Sustainable Outlook. To listen to past episodes and receive notices for new episodes, subscribe by searching Hub Talks, that's HUB Talks, in your favorite podcast app. We hope you will tune in next time to learn more about the outlook of the burgeoning sustainable economy.